2,000 distinct flower species are recorded within every single drop of honey produced by the colony. Worker bees cover dozens of miles of flight in just a few short days to gather these materials. One can notice how they collect microscopic beads of nectar from vast, sprawling fields before carrying the load back to the hive. But this is just the beginning. Inside the structure, the biological assembly line immediately takes over the raw material. Why does the entire colony pass the nectar from one bee to another? It would seem faster to simply deposit the load directly into the comb. But this transfer, combined with the constant fanning of wings, is strictly necessary to thicken the substance before storage. At first glance, the sealing of honey into perfectly uniform wax cells looks like a simple finish, but in reality, it completes a complex natural cycle before humans intervene. Modern production lines accept the harvest to extract and refine the product without altering its essence. It gets more complex further on. Every drop undergoes careful filtration to preserve the original golden hue and pure flavor of the liquid gold. 2 billion liters of honey are produced annually through this synchronization of insect labor and industrial engineering. The extraordinary industry moves in harmony with nature, preparing the product for its final journey. 150 United States dollars per kilogram is the price tag attached to the rarest forms of wild honey. Why does a simple natural sweetener command such a staggering market value? It would seem that honey is merely a common product found on every store shelf. But the answer lies in the vertical cliffs of Nepal and Bhutan, where harvesting is a deadly gamble against nature itself. Every drop is the result of thousands of small flights and the tireless work of an entire colony gathering the Earth's essence. But this is just the beginning. Hunters must suspend themselves in midair on fragile ropes to reach the hives. One can notice how they confront fierce swarms of wild bees deep in the forest canopies. They do this just to obtain a few liters of untouched nectar directly from the rock face. It gets more complex further on. Because of this harsh and perilous process, wild honey becomes liquid gold that few people will ever have the chance to encounter. It is visible how the thick substance drips from the cut combs during the dangerous harvest. Global demand continues to rise relentlessly, yet wild sources simply cannot keep up with the consumption rate. Humanity has been forced to seek a more sustainable path to avoid depleting nature. Transition to the next level. Consequently, organized beekeeping and seasonal harvesting become the only viable solution. At first glance, maintaining an apiary seems like a passive activity, but in reality, it requires blending traditional knowledge with contemporary techniques. This allows for a stable supply while ensuring the survival of the bee populations. Equipment gradually extracts the honey while preserving its pure original flavor. One can notice the golden viscosity as the product fills the containers without contaminants. This method ensures that the warm aroma and gentle sweetness remain intact for the consumer. The golden liquid is now ready for its final journey to the jar. Thousands of worker bees become the focus of attention when the first spring winds sweep across South Dakota, marking the start of the most meticulous task of the year. Beekeepers carefully inspect every single hive to assess the health of the colony and the activity level of the population. The queen bee, the heart that determines the survival of the entire group, receives the most critical examination. But this is just the beginning of the seasonal cycle. Why is the harvest delayed for nearly 2 months after this initial check? The process requires patience to ensure the product reaches maturity. But 6 to 8 weeks later, the hives begin to grow heavy with accumulated nectar. One can notice a smooth, white layer of wax sealing the cells, which serves as clear evidence that the honey has ripened. This visual marker confirms the substance has reached the ideal moisture level, allowing nature to preserve it long term. The labor of thousands of bees culminates in this specific physical state. The harvest initiates with a sense of ceremony, utilizing smoke rather than sharp knives or heavy machines. At first glance, blowing smoke from dry wood or tree bark seems aggressive, but in reality, it acts as a gentle sedative for the insects. The scent makes the bees believe there is a distant forest fire, triggering a survival instinct. They retreat deeper inside the hive to protect the queen and stores, allowing the beekeeper to work without causing panic. It gets more complex further on. The extraction demands absolute steadiness to avoid disturbing the colony. With movements as precise, slow, and gentle as lifting silk, the operator carefully removes each golden honey frame from the hive box. It is visible how a delicate brush softly sweeps away any bees still clinging to the comb, ensuring no harm comes to the resilient creatures. An unwritten rule of the craft dictates that beekeepers always leave a significant part of the honey behind. This reserve acts as a vital food source that helps the colony survive the harsh winter months. Thus, the tradition maintains a respectful balance between humans and nature on these windswept fields. Thousands of hives rise into the air simultaneously at large-scale farms in the United States and New Zealand. Heavy-duty helicopters gather crates slung beneath the fuselage, moving them swiftly across seemingly endless fields. The pilots maneuver to reach collection points before the weather changes. Why involve expensive aviation for transporting honey frames? It would seem that trucks could handle the task, but without the smooth flight, ground vibrations would compromise the quality of the product. Aerial transport reduces impact, keeping the honey as fresh as the moment it left the hive and preserving natural enzymes to the greatest extent. One can notice how the hive boxes float against the blue sky, gently twisting in the wind currents. At first glance, this looks risky, but in reality, it ensures the safest delivery by drastically shortening harvest time. Upon arrival, the frames are immediately moved indoors, but this is just the beginning. The crates enter a warming room where the temperature is strictly maintained between 37 and 40 degrees Celsius. This specific level of heat naturally thins the honey, preparing it for extraction. The process carefully avoids high temperatures that could break down nutrients. The material is now ready for the next processing step. High-speed rotating blades glide delicately across the surface of the warmed honey frames. This mechanical precision marks the entry into the uncapping machine, where each thin layer of beeswax is carefully removed. The sharp components lift off the cappings without grazing the delicate internal structure of the comb, exposing the cells underneath. Why is the comb structure carefully preserved during such an invasive procedure? It might seem easier to simply crush the comb to release the contents instantly, but in reality, keeping the structure intact allows the bees to immediately resume their natural cycle and continue developing the frame without the need for rebuilding. One can notice how the removed wax cappings fall away to be collected for recycling, rather than being discarded. Instead of becoming waste, this material is transformed into new foundation frames to ensure full sustainability throughout the production process. But this is just the beginning of the extraction journey. The honey-filled frames are immediately secured inside the centrifuge for the intense separation phase. The machine spins at extremely high speeds, generating a powerful centrifugal force that pulls the sticky liquid out of the cells. The fluid splashes against the extractor walls, while the comb structure remains undamaged for future reuse. At first glance, the extracted honey appears ready for the bottle, but in reality, it still carries small impurities like wax particles or fine dust. Therefore, the stream is sent directly to a coarse filtration system to achieve the highest level of purity. Specialized filter layers trap every remaining solid fragment as the honey flows through the mechanism. It is visible how the product becomes clearer and silkier with each stage of purification. This step is indispensable for producing a refined substance. Everything only gets more complicated further down the line as the liquid moves to stabilization. The filtered honey enters large holding tanks where a slow-moving agitator system gently swirls the viscous liquid to unify its flavor and color. This continuous motion dissolves any thick portions and prevents early crystallization before the final packing. Consequently, each batch must pass a strict quality control procedure before approval. Laboratory tests assess clarity, viscosity, and purity, while measuring sugar content and moisture levels down to the smallest percentage. Only perfectly balanced honey proceeds forward to the final station. 6,000 bottles per hour fill up rapidly on the automated packaging line. Advanced sensors measure the volume with absolute precision, ensuring not a single drop is wasted during the high productivity filling. The bottles immediately move to the capping station to be tightly sealed against air exposure and environmental contaminants. This final lock preserves the natural flavor and nutrients for the long term. The golden product is now fully ready to leave the facility. 1,500 meters is the absolute minimum altitude where the giant honeybee Apis laboriosa constructs its massive colonies on the vertical granite faces of the Himalayas. Unlike standard apiary operations in the lowlands, this process involves extracting a substance known as mad honey, which is derived exclusively from rhododendron nectar. The flowers contain grayanotoxin, a potent neurotoxin that imbues the final product with a deep red color and psychoactive properties capable of affecting the human nervous system. Such a harvest requires navigating sheer cliffs, where the air is thin and the terrain is unforgiving. But this is just the beginning. Why is this hazardous harvest restricted to a narrow window only twice a year? The environment appears stable year-round, but the rhododendron blooms specifically in spring and autumn, creating the only opportunity to collect the toxin-rich nectar needed for the honey's unique chemical profile. Preparation begins days in advance with the fabrication of climbing gear from local organic materials. Craftsmen select the straightest bamboo stalks from the forest to construct ladders that can span tens of meters in length. They braid rattan ropes with high tension, twisting fibers until they form a cable strong enough to support a human body against the rock wall. It gets more complex further on. One can notice how the team approaches the cliff base before dawn to utilize the calmer air currents for their fire. At first glance, burning leaves seems like a primitive method of pest control, but in reality, the thick white plume is a calculated countermeasure that disrupts the bees' defensive signals. The smoke slowly rises up the sheer rock face, enveloping the hives and inducing a temporary lethargy in the hundreds of thousands of insects guarding the comb. The lead hunter mounts the bamboo ladder, which hangs suspended by a single rattan rope anchored at the summit. It is visible how the flexible structure sways violently as the wind interacts with the climber's shifting weight. Upon reaching the target altitude, the hunter encounters the colony, where the bees, despite the smoke, launch defensive strikes against the intruder. They collide with the protective suits like hail, their stingers attempting to pierce through multiple layers of woven fabric. The operator stabilizes his position and uses a long bamboo pole to probe the hive's structure. A sharpened bamboo blade carves into the wax, detaching large slabs of honeycomb that glisten with a ruby-red viscosity. The process is only gaining momentum. Because gravity is the primary enemy at this stage, every cut requires a trajectory calculation to ensure the heavy slab falls directly into the basket suspended on the hunter's back. The ground team manipulates the guide ropes with millimeter precision to catch the load without tipping the climber. The basket descends slowly through the lingering smoke clouds. Workers immediately chop the wax structures into manageable fragments and press the mass by hand to extract the fluid. The mixture flows through slender bamboo filters, which trap dead bees and organic debris while allowing the liquid gold to pass into storage vessels. The presence of granotoxin is verified by the physical reaction, a bitter initial taste followed by a tingling sensation on the tongue. This confirms the chemical potency of the batch. The filtered mad honey settles into containers, completing the cycle of extraction from the wild cliffs. Thousands of kilometers separate the sweeping flower fields of South Dakota from the sheer cliff faces of the Himalayas. In the plains, hives line the ground in organized grids, while in the mountains, colonies cling to vertical stone. One can notice the vast difference in terrain between these two sources. But the geographical distance is only the first variable. Why do such distinct origins lead to a unified standard of quality? The raw material arrives from completely different worlds. The answer lies in the harmony that binds the tireless flight of tiny bees with the ingenuity of modern craftsmanship. At first glance, nature and heavy industry seem incompatible, but in reality, their integration ensures the preservation of the product. It is visible how liquid gold travels from deep forests and farms into the controlled environment of factories. Filters and centrifuges process the substance, removing physical contaminants. This turns the harvest into the crystallization of labor and culture. The technology completes the cycle of formation. The amber fluid fills the final jars. One can see the clarity of the material as it is ready for distribution.